Scientists finally found two of the Milky Way's missing satellite galaxies. What could this mean for astronomy? These discoveries also bring scientists closer to addressing a long-standing issue with the standard model of cosmology, known as the Lambda Cold Dark Matter (ЛCDM) model. In this model, cold suggests that dark matter consists of particles that move slower than the speed of light. The newly found small stellar communities have been named Sextans 2 and Virgo 3. They join about 60 known dwarf galaxies orbiting the Milky Way at a maximum distance of 1.4 million light-years. The most famous and largest of these Milky Way satellite galaxies are the Large Magellanic Cloud (LMC) and the Small Magellanic Cloud (SMC). Masahi Chiba, a professor at Tohoku University and the team leader, stated, "How many satellite galaxies does the Milky Way have?" This has been a significant question for astronomers for decades. Many of the Milky Way's small dwarf galaxy satellites remain undiscovered due to their distant and faint nature. However, Chiba and his colleagues were determined to find these elusive objects. They turned to the Subaru telescope, located near the summit of Mauna Kea, Hawaii. This powerful ground-based telescope is well suited for hunting dwarf galaxies, and the same team previously used it to detect 3 new satellites of the Milky Way. Many of the Milky Way's small dwarf galaxy satellites remain undiscovered due to their distant and faint nature. However, Chiba and his colleagues were determined to find these elusive objects. They turned to the Subaru telescope, located near the summit of Mauna Kea, Hawaii. This powerful ground-based telescope is well suited for hunting dwarf galaxies, and the same team previously used it to detect 3 new satellites of the Milky Way. This suggests that dark matter might be composed of currently undiscovered particles, though there are potential explanations that don't require expanding particle physics. For example, scientists have considered that dark matter might consist of tiny primordial black holes left over from just after the Big Bang. However, dark matter does interact gravitationally, affecting the motion and dynamics of light and ordinary matter. This has allowed scientists to infer the presence of dark matter and determine that large galaxies are surrounded by vast halos of this mysterious substance, which extend far beyond the galactic disks and visible matter halos. The ЛCDM model predicts that these dark matter halos play a crucial role in the evolution of galaxies. In the early universe, they formed gravitational wells that drew in gas and dust, which then formed stars. Eventually, these halos merged to create large galaxies like the Milky Way. The model also suggests that there should be hundreds of satellite galaxies around the Milky Way and other large galaxies. For instance, simulations using ЛCDM predict that our neighboring galaxy, Andromeda, should be surrounded by around 500 satellite galaxies. However, astronomers have only observed 39 dwarf galaxies orbiting Andromeda. For the Milky Way, some simulations, based on the standard cosmology model, suggest there should be around 220 dwarf galaxies orbiting it, but scientists haven't been able to locate them all. The discovery of Sextans 2 and Virgo 3 helps to balance this discrepancy. Nonetheless, the implications of these findings may present cosmologists with a problem opposite to the one they previously faced.